Okay, in this lesson, we're going to talk about graphing systems of linear inequalities. And this is going to really build off of what we learned in our last unit when we talked about linear inequalities. All we're doing now is adding another linear inequality on the coordinate plane. So let's look at our first example here. Here we have a system of linear inequalities. A system meaning that we have two or more inequalities. So if you remember back when we studied inequalities and graphing them, these are the ones where we actually have multiple answers. Unlike a regular system where you just have one solution, no solution, or infinitely many solutions. This is where there's truly an infinite number of solutions, and we represented that when we studied inequalities by shading a specific region on the coordinate plane. Well, we're going to do the same thing here. So let's go ahead and look at this first example. Let's go ahead and just focus our attention on the first inequality, and let's go ahead and graph that just like we already know how. So I'm going to start with my y-intercept of -3 with a slope of 1. And I'm going to go ahead and draw that all the way up my page. Okay. At this point, we have to recognize that the symbol is greater than, which means that we're going to have a dotted line. So I'm going to go ahead and I'm going to draw a dotted line to represent this inequality. Okay, now, just as a refresher of the last unit here, we have to test a point. And we've always talked about testing the point 0, 0. So if we test the point 0, 0, that would give us 0 is greater than 0 minus 3, which is 0 is greater than -3, which is a true statement. So what that means for us is that we're going to go ahead and we're going to shade everything that is on the side of 0, 0. Okay, that should all be review for us now. This is going to be the new part. I'm going to go ahead and I'm going to choose another color here. And I'm going to go ahead and I'm going to graph the second inequality. So I'm going to go ahead and graph my y-intercept of 3, and then I have a slope of -5. So 1, 2, 3, 4, 5 over 1, and it looks like I can only fit 2 dots on this coordinate plane. My symbol is less than or equal to, so I'm going to have a solid line going through those 2 points. Okay, hopefully those lines are a little straighter on your page than mine. Now, this is where the new part comes in. We also have to test a point as well. So I'm going to go ahead and test the same point, 0, 0. I'm going to say 0 is less than or equal to -5 times 0 plus 3. That's going to give me 0 is less than or equal to 3, which again is a true statement. Therefore, because that 0, 0 is a true statement, I'm going to shade everything on that side of my test point. And you're probably noticing that things are starting to get a little colorful here. Okay, now the solution to a system of linear inequalities is not only where the regions are shaded, but it's where they're double shaded. So if I grab, let's see if I can grab a highlighter here. If I grab a highlighter, you can see that this area here is going to be where all of the solutions to this system of linear equations are going to be. It's where the area that is, or the region we like to say, that's double shaded. So any of those answers within that region are going to be a solution. Now, I always get this really great question. Now, what about one of the points on this line right here? Like, what about this point right here? Is that a solution to the system? And the answer is no, because it's a dotted line. And that specific point lies on a dotted line. Now, if I said something like this point up here on the other line, the answer would be yes, because it is a solid line. And so all of those coordinates are going to be solutions. If you want to just check yourself, you can pick any one of those points and substitute it back into both of those linear inequalities, and you should get true statements for both of them. Okay, let's go ahead and try another one. I'm going to go ahead and pick some other pretty colors here. Let's go ahead and pick, oh, these are pretty. How about a light blue? That'll be nice. Okay, I'm going to do my first inequality. I'm going to go ahead and graph that. So I have a y-intercept of 2 and a slope of negative 1/3. So I'm going to go ahead and graph that out. You can see that my symbol's greater than, so that's going to give me a dotted line. So I just want to make sure that I dot my line, draw my lines real straight. It's great to use a ruler for these, so feel free to do that if you wish. Okay, I'm going to go ahead and test my point. And I always like to write it like off to the side. So 0 is greater than negative 1/3 times 0 plus 2. So it's really 0 is greater than 2, and that is a false statement. 0 is not greater than 2. So instead of shading the side that contains 0, 0, I'm going to go ahead and I'm going to shade the other side of my dotted line. Okay, I'm going to go ahead and grab a different color now. Why don't we get a pretty... How about this crimson, or how about this cranberry color? That's a nice color. Okay, I'm going to go graph my second inequality here. Y-intercept of negative 1 and then 2/3. Okay, my symbol is greater than or equal to, so I'm going to have a nice solid line here. Okay, and now I want to go ahead and I want to test a point. So I'm going to go ahead and test that 0, 0. And again, you don't have to test 0, 0. I just like 0, 0 because it's easy, because it always eliminates that number. So 0 is greater than or equal to negative 1. This is a true statement. So that means that I'm going to shade all of the points on the same side of that 0, 0. So you can see my shading is just lines, but if you have colored pencils, I'll bet yours looks a lot nicer than mine. Okay, so there we go. We have shaded both of them, and may I also recommend that you graph each of these inequalities separately. So just like I did the blue separately and I shaded, then the maroon one, do them separately. Don't draw the lines and then try to figure out where the shading goes. It's just, I don't know, I always find it to be a helpful tool. So if we're looking for the system, the solutions to my system, my solutions are going to be all of these points that are within the double shaded region. So any number that is in that point that is not on that dotted line, but it could also be on this solid line, are going to be solutions to the system. Okay, let's go ahead and take a look at a couple more. All right. I love these ones because they... we have to actually do some work. So you'll notice that both of these are not in slope-intercept form. But if you're asked to graph the linear inequalities, you have to put them in slope-intercept form. So there's just that extra step that you have to do here. So we have the first system. I'm going to go ahead and just quickly move him into slope-intercept form. And I will recommend to you being very careful with these, because sometimes, just like equations, we like to do these in our head, but you'll notice this next step that I'm going to do, I'm going to divide by -3. And remember that in this unit, anytime you divide by a negative, you have to flip the sign. So that's something that can be easily forgotten, so just be really careful about doing that in your head. Okay, so this is going to be one of my inequalities. And I'm going to go ahead and just solve the other one while I'm at it, so that we can just go ahead and graph them together. So I'm going to go ahead and subtract my x from both sides. That's going to give me -3y less than or equal to -x plus 3. And again, I'm going to divide by -3, which is going to cause me to flip my sign. So y is greater than or equal to 1/3 x minus 1. Okay, there are my two inequalities. Now let's go ahead and graph it. I'm going to make this super colorful just because we don't always have the opportunity to make things colorful. So we're going to take the opportunity while we have it. Okay, the first inequality. Let's go ahead and graph this guy. There's my y-intercept. And I have my slope of 1/3. And I have a dotted line that's going to connect these dots. So I'm going to make sure that I have a nice dotted line. And now before moving on to the next one in graphing, I am going to go ahead and I'm going to test my point. So I have 0 is greater than 1/3 times 0 minus 2. And it's going to give me 0 is greater than -2, which is a true statement. So I'm going to go ahead and I'm going to add my shading on my coordinate plane. Okay, and I'm going to go pick another pretty color here. I think, let's do maybe a hot pink. That'll be nice. Okay, and then my next inequality, here it is, -1. And then I have a slope of 1/3. That's interesting because it's the same slopes that I had before. But this time I have a nice solid line. There we go. Alrighty, and now I do want to emphasize something here because my shading doesn't really do it justice, but everything in here is shaded green. It didn't really look like that before, so I'm just going to kind of add it. Everything here is shaded. Okay, now I'm going to go ahead back to my pink, and I'm going to go ahead and test my point. So my point for this one is going to be 0 is greater than or equal to 1/3 times 0 minus 1. 0 is greater than or equal to -1, which is true. So I'm going to go ahead and I'm going to shade everything that's on that side 0, 0, 0. All right. So as you can see for this one, the solution to my system of inequalities is going to be where they overlap. So if I go ahead and I'm going to grab my highlighter, you can see that this region right here is going to be where all of my solutions lie. And where I went back and did those little green marks, that is not going to be part of the solution to this system of linear inequalities. It's just going to be the other ones. All right, great. Hopefully we're starting to get the hang of this now. Let's go ahead and do one more here before we start doing things backwards. So see if we can find another color that we like here. Oh, this is a nice one. Kind of neon blue. All right, I'm going to start with my top linear inequality, and I have to do some work here first, don't I? So I have 3x minus y is less than or equal to 3. Hopefully that's not hurting your eyes. And I'm going to go ahead and move my x to the right-hand side. And I always like to show my work, as you know, because it's easy to make a mistake if you don't. So I'm going to divide both sides by -1, which is going to cause me to flip that sign. So y is greater than or equal to 3x minus 3. Okay, there's my linear inequality. I'm going to go ahead and put them on my coordinate plane. And I have a couple coordinates that I could plot here. And this is going to be a nice solid line here. And let's go ahead and test a point. Test my 0, 0. Plug him into x and y. 0 is greater than or equal to -3, which is true. So it's not always going to be true, but in our case here it is. Okay, so there is my one shading. I'm going to go ahead and pick another color, and let's go ahead and see. Let's pick this red. That's nice. Y is less than or equal to 3. Well, again, remember y, if you flip y upside down, it looks like an H, and H is for horizontal. So this is going to be a horizontal line. That's a solid line, and it's going to be right on 3. Okay, perfect. Now for this one, we do not need to test a point, because what it's saying is y is less than or equal to 3. And we know that less than or equal to 3 is going to be everything that is going to be in this direction on our grid. So if we want to know what our solution to this system of inequalities is, it's going to be that double shaded region. And it's going to be that region that is over in this direction here. So it's really nice using two different colors in this section, but if you don't have two different colors, just be very careful to make sure that you're looking at the double shaded area and not just the, the single shaded area. And also one thing that I noticed that pops up every once in a while is that we sometimes erase our shadings. Don't erase the shadings. They're there for a reason, so just leave them and they will help you answer the problem. Okay. Just like before, we're actually going to go backwards now. And I'm going to spend a little bit more time on this because I had a recommendation from a student to kind of go a little bit slower on this topic because it's kind of challenging. So let's chat about this. We did review this back in the last section, but I'm going to go a little bit slower here, and I'm going to give you a little bit more to bite into. So look at this first coordinate plane here. We want to figure out what is the solution to the system, what is the actual system that's being generated here. We know that all the solutions are going to be in that shaded region there, and so we need to figure out what is going to be the system that's going to represent it. So I'm going to break this down. Let's go ahead and work with our solid line first, the one that I just starred. The way that I always like to start these is by asking myself, well, what is the linear equation that is being represented here? I know we're working with inequalities, but what's the linear equation? And it looks like what we have here is y is equal to, what is that? It's going to be negative x plus 2. Okay, that is the linear equation that is represented. But obviously, I don't want to use an equation. I want to use an inequality. So what I want to do is I'm just going to put a circle there, or actually even a box might be really helpful because we're going to try to fill in that box with the proper symbol. Now, here's what we're going to do. We're going to use a test point. So I'm going to use that test point 0, 0. So I'm going to say 0, and I'm going to put a box there. Negative 0 minus 2. I'm going to eliminate that 0 there, and now I have 0 with a box and a negative 2. You're probably thinking, what is she doing? Well, let's just kind of look at it here. If you look at my shading, you can see that 0, 0 lies on the side that is not shaded. So basically, if I were to have tested 0, 0 right here, I would have gotten a false statement. So in order to get a false statement, I needed to use the symbol less than or equal to, because 0 is not less than or equal to negative 2. It's greater than. So this would be a false statement. I also use the less than or equal to because it's a solid line. So kind of going back to the main part of this problem, if I took this symbol back up to my original, I would have y is less than or equal to negative x plus 2. And that would be one of the inequalities of this system of linear equations or linear inequalities. Let me try the other one. If you didn't catch that that time, I'm gonna do another one. Actually, I'm gonna do a couple more here so you'll be able to see. Okay, now I'm gonna focus my attention on my dotted line. Okay, here's my dotted line, and I'm just going to start by writing my equation of this inequality. So y is equal to, I know it's an inequality, but just for the purpose of the example, and it looks like my slope is going to be 2/3 x minus 3. Okay, now I know I'm not doing an equation, so what I'm going to do is I'm going to replace it with a little box because I want to fill that box in. Okay, so this is really what I have now. Now I'm going to test 0, 0. Okay, if I test 0, 0, here's what it's going to look like. It's my little box. My 2/3 is going to eliminate just like as it always has, and I'm going to be left with 0. Put my little box there with negative 3. Now, this is where we want to determine true or false. Now, if you look at our dotted line, we can see that the shaded region is going to be everything on this side of the dotted line. which would end up being a true statement as we create it. So I want to put in my box here a true statement. So I'm going to say 0 is greater than -3. I also chose greater than because it's a dotted line. Therefore, my inequality is going to be y is greater than 2/3 x minus 3. And what we have here is the system of linear equations that was used to create this picture. Okay, let's try another one. So hopefully that was a little helpful tool to help you do this. If you don't need to use that little box and that little method that I did, that's perfectly fine. But I just wanted to kind of show you that. Okay, let's take a look at this one. So I'm going to go ahead and I'm going to work with this guy right here. Let's go ahead and figure out what his equation is. Y is equal to, looks like my slope is -x and then -3. Okay, so y, I'm going to put a little box there, -x minus 3. And I'm going to go ahead and put 0, 0 in there. So 0, box, -0 minus 3. So 0 with a box, -3. Okay, now if you look here, the shaded region is going over 0, 0. So I want a true statement here. So I'm going to say 0 is greater than -3. So my linear inequality would be y is greater than -x minus 3. That would be what I have starred in pink. Okay, I'm going to go ahead and I'm going to pick the other one. I'm going to be working with the other dotted line. Start with my equation. Y is equal to, it looks like it's going to be -x plus 1. And I'm going to say y, I'm going to put a box there. And I'm going to substitute 0, 0 in. So 0 with a box minus 0 plus 1. So that's going to give me 0 with a box, 1. And this time it looks like 0, 0 is also true. It looks like it's shaded in the other direction. So 0, 0, I need to make this true. So it's going to be less than. So my inequality is going to be y is less than -x plus 1. And what I have put in a box here would be the solution, or would be the system of equation that is representing this picture up here. Okay, I have one more problem for you. Sorry that this lesson is a little bit long. Feel free to speed up or slow down as you wish. Here's another one. This time it asks me to not only graph the system of linear inequalities, but then from the given points, select each point that is a solution to the system of inequalities. This is a great SOL question. So let's go ahead and do this. Let's go ahead and graph the first one. At this point, the graphing should look pretty good. Okay. Whoops. Okay, this is going to be a solid line. So I'm going to go ahead and draw my solid line through my dots. It's a pretty straight line. All right, and then I'm going to go ahead and do my shading. So 0 is less than or equal to -0 plus 3. So 0 is less than or equal to 3, which is true. So I'm going to go ahead and I'm going to shade everything on this side of my green line. I'm going to go ahead and choose a different color here. And I'm going to go ahead and graph my other one. So -2, and I have a slope of 4. So 1, 2, 3, 4. And I'm going to have a dotted line this time. So let's see if I can have a nice dotted line going up my page. Okay. My test point is going to be 0, 0. So I'm going to test my 0, 0 in there. So 0 is greater than -2. That is true. So all the points on the 0 side are going to get shaded as well. Okay, so just for the purpose of this problem, I am going to go ahead and highlight the solutions to the system, just to remind myself that just because it's shaded doesn't mean it's a solution. It's only if it's double shaded. So these are the double shaded, this is the double shaded region. Now I'm going to go ahead and answer the question. So from the given points, which ones are solutions? So -1, 4. -1, 4 is going to be this let me choose a different pen color actually, let's do blue, is going to be this point right here. And you can see that because he lies on that solid line, he is going to be a solution to this system. All right, -5, 2. 1, 2, 3, 4, 5, 1, 2. This is clearly a solution because he's in the doubly shaded region. 0, -2 is going to be right here. Notice that he is on the dotted line. If he's on the dotted line, that he's not a solution to the system. 0, -1. He's pretty close, but it definitely is going to be a solution. He's going to be in that double shaded region. -1, -1. He's also another one that is in that double shaded region. And then the last one, 2, 1, right about here. He's definitely on that solid line, but he's not part of the area that is doubly shaded. He's kind of off to the side. Now, let's say that you weren't sure about this point. Well, let's go ahead and take that point and substitute it back into our system. I'm going to first take him and put him into the first one. I'm going to say that, 1 is less than or equal to -2 plus 3. So that would give me 1 is less than or equal to 1, which, yes, that is true. Let's go ahead and check the second one. I have 1 is greater than 4 times 2 minus 2. So I have 1 is greater than 8 minus 2. 1 is greater than 6, not true. So if you're not able to surely, be confident that a point is a solution, just go ahead and put it into your system. And it has to be true for both of the inequalities in order to be part of the solution set. So this is not a solution to our system. Okay, that is the end of the section on linear inequalities.